Welcome. In that video, we are going to focus on novel view synthesis on 3D reconstruction from a single or few views. So in that paper, we're going to focus on NeRF, on the PixelNeRF paper. That paper works both for single view synthesis, for single view reconstruction. So from a single view, enabling the generation of novel views from any viewpoint, but it's also able to work with multiple views. Here, for example, we have an example of 3 views from a scene that the model has never seen, and the model is able to render novel views from that from those views. You can see a comparison between the generated frames by PixelNeRF towards related to NeRF. So if you just do a NeRF reconstruction from those 3 input views, you have very bad results, while PixelNeRF, by using a prior that is learned from being trained on multiple scenes, is able to do a meaningful reconstruction. So in that video, we're going to see how that works in details. So basically, I assume that you have knowledge about NeRF and about volumetric rendering. If that's not the case, I invite you to have a look at all my other videos. And if you want to go further, I also have a course on Udemy about NeRF. I will put the link in the description if you're interested. So basically, as with traditional NeRF, we have a camera, we're shooting rays in the scene. And then for each, we're shooting rays in the scene, and then we're sampling points along the ray. So far it's just similar to NeRF. And for each 3D point, so each query point, for which we need to predict the color or the density with a NeRF model, we will project those points to the 2D images we have as input. So for example, in that example, we have a single image, so we are projecting the 3D point to that image. For that example, we have 3 views, 3 images, and therefore we will project the point to each image. And then what we are going to do is to query features from those images. So basically, we have a CNN that has been pre-trained, and the CNN extract features from those input views. And then each 3D point is a set of features coming from all the images. Then we're aggregating those features. We will explain how this is done in a moment. For example, we could just take the sum or the mean, so that our model is agnostic to the number of views. And then what we do, we feed those features together with the position and direction of the 3D point. The 3D position of the point, of the query point, on the direction of the ray. So basically, this is standard NeRF approach. But what we do, in addition, we add the features that we have that we got from the 2D images. And because this NeRF has been pre-trained, and therefore that it has learned to use the features appropriately, it predicts the RGB and density for each 3D point. And then everything to the right is just standard NeRF or standard volumetric rendering. Then we can compute the volumetric integral and estimate or predict the color of the pixel. So that's for inference, and for training, it's the exact same procedure, but the model is supervised from the real or the ground truth pixel values. So that's a very let's say simple technique. That's very simple, but that's very efficient. This paper is a kind of baseline for a lot of other papers on the other approach. And it works very well. Okay, I thought they were explaining the way they aggregate information. I think it's in this supplement. Yeah, so basically they are using, I think it's ResNet. Oh yeah, they are using a ResNet. So basically they have multiple ResNet with shared weights. Well, they have a ResNet or res block. So for each input view, or for each well, let me double check that. Yeah, okay, so basically each feature, so for each image, we are going to predict I'm sorry that it's a while that I read the appendix, so I'm trying to figure out what's happening. But basically what's happening is that there is the NeRF model apply this res block with shared weights to each feature individually. So the position and direction, I believe, are the same. yeah, so basically n is the number of images. So basically each feature is different. Okay, so basically the head of the neural network treats each feature independently, and then in the middle of the neural network there is an average. So it takes the mean of all those intermediate features, or all those features map, and then there is the tail of the neural network that predicts the final RGB on sigma value. Yeah, so basically what you could do is to aggregate information before feeding it to the neural network. But here what they do, they first extract intermediate feature map and then take the mean of them. There are other papers such as the GRF paper that have more advanced aggregation mechanism. For example, they're using self-attention, maybe not self-attention, but some attention mechanism, and they predict like weights for each feature, and they're applying a weighted sum to aggregate information. And in some way that's a bit more powerful, because then it for example, there are some views that may be occluded, and by using an attention mechanism, they can give more or fewer weights to those views. So again, that's it for the technique. Very simple. Yeah, let me know if you want me to implement that paper. We can implement it. It's always on that channel in about 100 lines of code in PyTorch. Yeah, let me know if you're interested. We can have a quick look at the results. So we've already seen that in the first page. But here we see some results, a single input view, and then the novel views. You can see a comparison with SRN, which is another method, with the method and the control method. With some other comparison, we can see that, for example, SRN has some issues with the colors on that example, and with the fine details on that example. Okay, here we have an example with two input views. So yeah, it's very great. The method, because of the aggregation mechanism, can work with n views, on n can be 1 as well. It is not, you don't need to define the number of views. Okay, the same kind of examples on ShapeNet. Later with some other experiments that are maybe more interesting. Here, for example, we have 3 views on a held out scene, so a scene that the model has never seen, and we see the novel views on a comparison to NeRF, and we can see that NeRF is doing very, very bad. And here we have a comparison to NeRF versus the method. So you can see with only a single view, there is a big difference in PSNR. As PSNR is a logarithm metric, well, operates with a logarithm scale. This is very huge. Even here, when there is a very small a difference in PSNR, that is a very big impact on the quality of the image. So we can see that with 6 views, we're doing, yeah, the method is doing better than NeRF. And then since 9 views, NeRF is doing better. It's also maybe because this model has been trained with only 3 views, I think. Yeah, it has been trained with only 3 views. So maybe training it with more views might help. And also, as opposed to NeRF, which is trained on the scene specifically, this method is working on the fly. It doesn't need training at inference time. So that means you just feed 3 input views and you get your results in a few milliseconds, or maybe in a few hundreds of milliseconds, but you can optimize that by optimizing your neural network. Well, optimizing the architecture of your neural network. Yeah, I might do a few videos about that. Let me know as well if you're interested into real-time neural networks, about compression, distillation, things like that, or next TensorRT. Yeah, just let me know in the comments. But yeah, basically with a NeRF, even if you have only 9 views, you need to train the NeRF model. If you are using vanilla NeRF, it can take a few hours. Well, it will take a few hours, and it can take up to 2 days. So yeah, here this method is working on the fly. Okay, so I think that's it for this paper. I have a few videos not related to paper review, but to paper implementation, where we have implemented all the papers to do novel view synthesis from a few input views. We used meta learning, some other regression in the loss. So yeah, there are really a few videos about that on my YouTube channel. So if you're interested, have a look at them.